There are two common ways of representing probabilities in logistic regression. One approach, which is the approach I want to cover in this module, is to report changes in the probability of the dependent variable across the values of a particularly interesting independent variable while holding all the other variables in the model constant at their sample-wide means. This is called marginal effects at the means, or MEMS. In this model that we just ran, in which age and education are both used to predict turnout, we might allow education to vary from, say, 0 to 20, seeing how the probability of voting changes, while holding age constant at its sample-wide mean, which is 46.1 years. Here is the logistic regression model that SPSS estimated for the voted 08 EDUC age relationships. Now, the following equation would permit us to estimate the logged odds of voting at any value of education holding age constant at its mean. Notice the only change here is now, instead of age as a variable, age has been set as a parameter at 46.1. Now, to retrieve the probability of any dependent variable binary in a logistic regression model, the probability is retrieved, here's the generic expression, through this equation. Applying that equation to the current example, we would have the probability of voting would be equal to this expression, now we could run through every value of education, I suppose, and plug it into this model and retrieve probabilities. We can get SPSS to do it, although SPSS, truth be told, is not all that friendly when it comes to computing predicted probabilities. You do it in compute, of course. We're going to go transform compute. I have set it up. We'll call the predicted probability of voting across values of education as PRE underscore EDUC. Here's the expression we just looked at in the numeric expression box. Notice that education is varying here, and we have set age constant at its sample-wide mean of 46.1. I've also supplied a label. This is always a good idea. We'll call it PredProb, predicted probability, EDUC, voted 08, and then comma, mean age, so we know exactly what those predicted probabilities are. I'm going to hit continue. Okay, it's going to ask me if it wants to change my existing variable because I'd made this run a couple times this morning. I'll just say okay. Now let's see how the predicted probability of voting changes across values of education while holding age constant at its sample-wide mean. We would go analyze, compare means. The dependent is going to be, of course, pre-EDUC. That's a predicted probability. The independent, which we've allowed to vary, is EDUC. That goes in the independent. I'm going to go to options and get rid of standard deviation to make it a nice lean table. And we will hit OK. Here we go. Here are folks with no formal education all the way down to respondents with 20 years of education. At low levels of education, the predicted probability is quite low indeed, 0.0663 for those with no education. And you may notice how it does increase as education increases. Again, this is at mean age, so we've held that constant. This is for average respondents in terms of age. It increases all the way to 0.9413 among those with 20 years of schooling. This is a very interesting relationship. We will see in a minute how it does fit a nice logistic curve. Researchers sometimes ask, or they use a sort of a point of reference, the two values, will reference the two values of the independent variable between which the probability of the dependent variable switches from a probability of less than 0.5 to a probability of greater than 0.5. And that, in this data, occurs right here between 9 and 10 years of schooling, 0.4485 for 9 years and 0.5161 for 10 years. That's sometimes called the instantaneous effect, and that's always the point, the interval in the independent variable that has the largest marginal change in the dependent, and also it contains the 0.50 when the probability switches from less than to more than 0.50. Let's graph this. I'm going to go to graph, line, simple, define. I've got it set up. We just want mean values of pre-EDUC across categories of EDUC. Here's the basic graph. That looks pretty good. A little time in the editor, and you could have a graph that looks like this. This has a reference line drawn at 0.50, so you can see that instantaneous effect right there.